Welcome back. In today's class, we will be solving a few more numericals based on triangle. In the first sum, what we can see is we have a given triangle BQD. In that triangle, the conditions which are given is BP is equal to BC. So this is side BP and this is BC. That means this angle and this angle will be equal. This triangle will be isosceles triangle. Second condition which is given is DQ is parallel to CP. DQ is this side and CP is this side. So these two lines or sides are parallel. And the third condition which is given, that CPD, this angle has been marked as X, and this exterior angle to this triangle has been marked as 4x. That means this angle is 4 times of this internal angle CPD. Now we have to prove the first thing is CP is equal to CD. CP means this side is equal to this side. That means CPD, this triangle will be an isosceles triangle, and also DP bisects angle CDQ. So this is DP and this is our angle CDQ. So from the first condition, what we are getting is angle BPC will be angle equal to angle BCP. And from this triangle BCP, what we are seeing here is that this exterior angle which has been marked as 4x, this exterior angle will be equal to the summation of this opposite interior angles with respect to this triangle BCP. So we can say that summation of these two angles is 4x and these two angles are equal to each other. That means individually they will be 2x. Again, with respect to triangle CPD, this angle BCP is the exterior angle and this will be again equal to the summation of the opposite interior angle. That means this angle and also this angle. And already we know that CPD, this angle is equal to x. That means angle CDP will be equal to 2x because we have already derived or already proved that angle BCP is 2x and angle CPD is equal to x, that is given. So angle CDP will be x. In the triangle CPD, what we can see is these two angles are same. That means these two sides will be corresponding, opposite sides will be equal. That means CP will be equal to CD. So the first part is already proved. Now the second part. In the second part we need to prove that DP bisects angle CDQ. So this is angle CDQ. This part CDP, this is already X that we have already proved. Now this CP is parallel to DQ and then PD or DP, this is the transversal. So we can say that angle CPD will be equal to angle PDQ because they are alternate angles. So what we can see is angle CDP, that is also X, and angle PDQ, that is also X. So since these two angles are same or equal, so we can say that this side, this line DP, this bisects this total angle CDQ. Now the second sum, what we can see is in the given figure, it is given that OA is equal to OD. So these two sides are equal and also these two angles are equal. This angle which are marked as angle 1 and 2, these two angles are equal, and we need to prove that this triangle OCB is an isosceles triangle. That means we need to prove that these two sides OC and OB, these two sides are equal. So for doing that, what we can do is we can choose this OAC, this triangle, and ODB, this triangle, and then we can prove that these two triangles are congruent triangles. And if we can do that, then easily we can prove that these two sides are equal and that the given triangle will be an isosceles triangle. Now what we can see is if we choose these two triangles, then this angle which has been marked as 1 and this angle CAO or CAB, these two actually form a linear pair, means this angle and this angle. So that means summation of these two angles will be 180 degree, and also this angle which has been marked as 2 and this angle BDO or BDC, these two angles also form a linear pair. And since this 1 and 2 are equal, that means their remaining part of those linear pairs will be also equal because their summation is 180 degree. So angle OAC is equal to angle ODB. Also, the condition which is given is OA is equal to OD. So these sides are equal, corresponding sides of those two triangles, and also this angle, angle AOC and angle DOB, these two angles are also equal because they are opposite angles. So from these two triangles, what we can see is these two corresponding angles are same, these two corresponding sides are same, and also these two corresponding angles are same. So we have angle side angle congruency between these two triangles. So easily we can say again this corresponding side OC will be equal to OB. That means this triangle OCB, this will be an isosceles triangle. Now the next sum, in the given figure, angle ACB is a right angle. So ACB is a right angle. That means angle BCF, that is also a right angle, and then AC is equal to CD. So AC is equal to CD. These two sides are same. That means these two angles will be also same or equal. And then CDEF is a parallelogram. CDEF is a parallelogram. And if angle FEC is equal to 10 degree, FEC is equal to 10 degree, then we need to find the measure of this angle BDE. BDE, that means this angle. So since this is 10 degree and angle ECF is equal to 90 degree, that means angle CFE will be 180 minus their sum. So it will be 180 minus 100, so 80 degree. And since CDEF is a parallelogram, that means this angle and this opposite angle of that parallelogram, diagonally opposite, these two angles will be equal again. So that means we can say angle CDE, that will be also 80 degree. And since again CDEF is a parallelogram, so DE will be parallel to CF. So angle CDE, that will be equal to angle ACD, since these two are alternate angles. So this is 80 degree. Now if we consider this triangle ACD, then one angle is already we have found out, that is 80 degree, and the summation of then other two angles, remaining two angles will be then 180 minus 80, that will be 100 degree. And as per the given condition of this problem sum, AC is equal to AD and these two angles are same. That means the individual value of those, the measure of those individual angle will be 100 by 2, 50 degree, right? So now angle ADC or CDA, that angle we have already obtained, and that is 50 degree. This angle also we have already obtained, that is 80 degree. So the remaining angle, because these three angles, this summation of these three angles will be 180, because AB is a straight line or straight angle. So the remaining angle will be then 180 minus summation of these two angles. So angle BDE is equal to 50 degree, which we were supposed to find out. Now the next problem sum. Now in the next figure, we can see that straight lines L and M are parallel and P and Q are parallel. And we need to prove that triangle ABC and triangle CDA, these two are congruent. Now since this line L and M, these are parallel, and with respect to that pair of parallel lines, AC is the transversal, so we can say that this angle and this angle, these two angles will be equal because they are alternate angles. Now again, since this line P and Q are parallel lines, and with respect to that again AC is the transversal, so we can say that DCA, this angle, will be equal to BAC because again these two angles are alternate angles. So between triangle ABC and CDA, these two set of angles are equal, and also AC is the common side between these two triangles. So what congruency we have? So we have angle side and angle congruency between these two triangles. So now we can say triangle ABC and triangle CTA are congruent triangles. Now in the next sum, in the given figure, ABCD is a square, EF is parallel to BD. EF this line and BD is the diagonal of this square. These two lines are parallel, and also it is given that EM is equal to FM. Now we need to prove the first thing is DF is equal to BE. DF is this much and BE is this much. So these two line segments will be equal, that we need to prove, and then we will come to the second part. So what we can see and what we can say is, since this is a square, so all the interior angles are 90 degrees. And since it is given that BD is the diagonal of this square, so we know that diagonal bisects the interior angles, the angles that it is part of. So we can say this angle and this angle, they will be equal. And since this angle, the whole angle, interior angle is 90 degrees, so this much will be 45 degrees. And since BD is parallel to EF, and with respect to that, if we say that CD is the transversal, then what we find is this BDEF, this angle will be equal to this angle because they are corresponding angles. And from the other side also, this same diagonal BD also bisects this interior angle ABC. So again DBC will be 45 degree, and from the same concept with respect to these two parallel lines BD and EF, these two angles will be again corresponding angles and their measurement will be 45 degree. So what we can see here is that angle EFC will be equal to angle FEC because these two angles are 45 degree. So we can say that this triangle CFE is an isosceles triangle, and so these two sides, the opposite sides of those two angles, equal angles, will be also equal. So we can say CF will be equal to TE. And again we know, since this is a square ABCD, so we can say this, so the whole side CD will be equal to CB or BC. So it will be CD will be equal to CB. Now if we subtract this part from the whole side, so we can write this way, that CD minus CF, that will be equal to CB minus C, right? So rest of the part, remaining part will be what? That will be DF. From this side, DF will be equal to B. Next we will prove the second part of this sum, which is AM, this line, this bisects the angle BAD, which is 90 degree. Now from these two triangles ADF and ABE, we know that AD will be equal to AB because this is a square ABCD, and we have already proved that DF is equal to B, and also we know that ADF, this angle is 90 degree, and ABE, this angle is also 90 degree. So what type of congruency we have between these two triangles? We have side, angle and side. So side, angle, side congruency we have between these two triangles. So these two triangles are congruent, and we can say that AF will be equal to AE, and also at the same time this angle DAF will be equal to BAE. Now next we will prove congruency between these two triangles AMF and AME, because to prove that this AM, this side, if it bisects this angle BAD, we need to prove that this angle, this total angle, this will be equal to this angle, right? And one part has already been proved, so the remaining part has to be proved that they are equal, and for that these two triangles we need to choose and we need to prove the congruency between them. Now if we consider these two triangles, we have just now proved that AF is equal to AE, and also we know from the problem statement that EM equal to FM. So these two sides are also equal. EM is equal to FM, this is given, And also what we can see is AM. This is a common side, so we can say AM is equal to AM. That means between these two triangles, all the corresponding sides are equal. So we have side congruency between these two triangles. So if these two triangles are congruent, then we can say that angle FAM, this angle will be equal to EAM, the remaining part of the angles that we are supposed to prove that they are equal. So we can say that angle FAM and angle EAM, these two angles are equal. And now if we add these two angles, angle DAF and angle FAM, and on the other side if we add angle BAE, this angle, and EAM, this angle, then their summation will be also equal. And summation means what? Angle DAF plus angle FAM is nothing but angle DAM, and on the other side, summation of these two angles that we have written here, that is nothing but angle BAM. That means these two angles are equal. So we can say that AM, this line bisects angle BAD. So this much for today. In the next class we will solve a few more problem sums. Till then, stay safe and stay healthy. Thank you.